Okay, so we are going over 7.5, which is called circular reasoning, and it's called practice understanding. So, what we're really doing is we are looking for you to apply everything that you've kind of learned in this unit. And so it says how, so you're applying circle geometry theorems in various contexts. And how do I examine a complex geometric figure for structures and features that will support my reasoning? And how do I use properties and theorems of circle geometry to model real world contexts? So we're going to be doing this problem, and then that's it. The rest of the lesson, I'm gonna have I'm gonna talk about it during class. So it says the following problems will draw upon your knowledge of similarity, circle relationships, and trig. In the diagram, the radius of D is 5 centimeters. So the radius of circle D is 5. So whenever they tell me that, the very first thing I go after is I start labeling every single radius as 5. Okay. I'm not going to label this other radius right here to right here. I'm not going to label that one because it gets a little sloppy in there. So I won't be doing that one. Okay. And then it says, and F is the midpoint of AE. So the moment that someone tells me something is the midpoint means that there are two congruent segments. So those two segments are congruent. Okay. AF and FE are now congruent. Segments GE and GA are tangent to circle D. Tangent to circle D. So, what was the theorems that we learned about segments that are tangent to circle D? So, the first one that you should be thinking about is that they're perpendicular to the radius. So, because I know that, I'm going to be marking this to be perpendicular and this to be perpendicular. But not only that, I call it my snow cone theorem, where this section is congruent to this section. Okay. And it says the measures of arc EB and BC are given in the diagram, which that's true. Here's the 40 and here's the 60. Okay. Find the measures of all of the other unmarked angles, arcs, and segments. Okay, there are a lot of things going on here. So the very first thing that I'm going to go after is anything with a number. I'm going to try to go after. So I already marked my radii, and now I'm going to go after my arcs. So because arc EB is 40 degrees, that tells me about my central angle. So his central angle will be 40 degrees. So there you go. He's 40 degrees. Okay. Let's see. I don't have a central angle for that 60. So I am now going to go over, let's see. I'm going to go over, let's see. This arc BC is 60 degrees, that intercepted arc. His inscribed angle is angle BAC. This angle in here, BAC, right? This angle here. So I'm going to find him because we know that the measure of the arc and the inscribed angle are related, right? And so because that's 60 degrees, then that means this back here is going to be 30 degrees. And I could do the same thing for arc EB and angle EAB. So go ahead and figure that out. You should figure out this angle in here. What is this angle in here? Since we know his intercepted arc, his pizza crust is 40 degrees. What is that angle? And we know that that angle will be half of the intercepted arc. So that means it's going to be 20 degrees. Very good. Okay. Okay. So there's a couple other things that I'm seeing here. Um, let's see. I know that, let's see, I know, oh, okay, here's another one. Because I know that this radius is congruent to this radius, I know that this angle is congruent to this angle, right? And those two angles are congruent because of the triangle, isosceles triangle angle theorem, which basically says they're congruent. Now, if the vertex angle is 40 degrees of that triangle, then those two angles there is going to be 180 minus 40, which would be 140. And then those two angles would have to share the 140. So that would be 70 degrees. So let me show you 70 degrees there. So if you notice, all I'm doing is I'm picking something and I'm figuring it out. Okay. Another theorem that you learned was that if you have an inscribed angle, so I'm specifically talking about this inscribed angle, who intersects with this, with the diameter, right? Then this angle right here is a right angle. So I can know that. Let me erase some of that. Which means if I looked at this yellow right triangle, then that means I can find this angle up here because of that right triangle. So go ahead and find the angle of that right triangle, the measure of that angle. And you're hopefully saying, oh, Miss Johnson, I know what it is. It's 60 degrees. And I'm like, exactly, it's 60 degrees. And because I know that inscribed angle, I also know this pizza crust out here, right? And some of you are thinking, oh, Miss Johnson, but I could have known that because that's a semicircle. Exactly. There's more than one way to figure this out. So go ahead and figure out arc AC. What is the measure of arc AC? Okay. And some of you are like, oh, Miss Johnson, it's 120. Very good. So a couple different ways that you could figure it out. It's 120. The first way is it's an inscribed angle and there's his intercepted arc. So he's 120 degrees. Another way that you guys could have figured this out is if you said, I know that this from BCA is a semicircle. So therefore he has to be 180. So this leftover part has to be 120. Exactly. Okay, let's just move on a little bit more. Let me see, what else do we know? I'm going after angles right now for some reason. That makes sense to me. Okay, so the other thing that I see is I see this triangle. Now I see two sets of congruent triangles here. Do you guys all see my two sets of congruent triangles? Yeah, I see triangle GED is congruent to triangle GAD. Those two triangles are congruent because of side, side, side. But also GAF is congruent to GEF, right? Those are true. So that means that those two are going to be congruent. So lots of things are now going to be congruent. I could say these angles are congruent. And for GEF, these two are congruent. This angle here and this angle here are congruent. But the only way they can be congruent and next to each other like that, forming a line, would be if those two angles were 90 degrees. So I'm actually going to erase this and like show you that these are all congruent, like they're all right angles, right? And because I know that, that means I can figure out a bunch of angles in here, right? And then even in here. So this is where I'm going to pause and I'm going to talk about it more in class. But I wanted to get you started to think about these things. So the next steps is I want you to look for angles that you can find and even side lengths that you can find. Okay. And I'll give you a clue because you have this triangle being a 30, 60, 90, you know how long these two sides are. And because this is a 90-degree angle here, you can find a bunch of angles here. Okay. So with that being said, I'm going to leave you here and then have you finish. And then I think this is a pretty good start. So things that we used were we remembered that the central angle and his intercepted arc are exactly the same, 40, 40, versus an intercepted arc and an inscribed angle. Miss Johnson likes to call them onscribed angles because this is 30 degrees. It's half of the intercepted arc. We also remember that a tangent to the radius at the point of tangency is perpendicular. And we also remember that if you have an onscribed angle and it intersects a diameter at the endpoints, then that is a 90-degree angle here. That angle is 90 degrees. We also use the fact that right triangles have triangles have 180 degrees as the sum of the measures of all the interior angles of a triangle. And so I want you to practice all those. Okay. So thank you very much. Have a great day.